Good morning, students. In the last class, we discussed about the history about the periodic classification of elements. We discussed the Dauvergne triads, Newlands octaves, Rothermeier curves, as well as we started the discussion about Mendeleev's periodic classification of elements, and about the periodic table he given we already discussed yesterday. Now let us discuss mainly about the merits and demerits of Mendeleev's periodic classification. Okay, coming to the yesterday's topic, continuation to the topic, okay, the heading is merits and demerits are first mainly give the subheading as merits of Mendeleev's periodic classification of elements. Now coming to the first one, a very important merit we need to know about this Mendeleev's periodic classification of elements is, till that Mendeleev, we have discussed many classifications, they failed to include all the known elements by that time in their classification. Okay, but coming to the Mendeleev, he placed all the known elements, whatever were discovered in the by the time of Mendeleev, he placed all those elements in the table. Along with that, he left some spaces for the undiscovered elements. Okay, so that is the main merit of Mendeleev's classification. Okay, so because of those gaps he given in the periodic table, so the people came to know there is a scope of finding these or discovering the elements. Okay. So the main merit of Mendeleev is he left some spaces for undiscovered elements. In his periodic table. Okay? The people are failed to place the known elements in the table. He placed all the known elements. Around 63 elements were discovered by the time of Mendeleev. He placed all the elements in the periodic table, as well as he left some blank spaces for the undiscovered elements. And even he guessed the atomic mass of that undiscovered element, as well as he expected or he given the properties, means what type of compounds the element can form, was also successfully explained by him. Okay, because it is proved correct after discovering those elements. Okay, now coming to the naming of those such type of undiscovered elements, he given the name starting with the term Eka. He kept a prefix Eka. Eka means unknown. Okay, he left a space behind his element boron, and he named that undiscovered element as Eka boron. Okay, next in the same manner, he left a space after aluminium, and he named it as Eka aluminium. In the same way, Eka silicon. So, okay. So he left the blank spaces for the elements and he named them with the prefix Eka. Okay. Boron was discovered by that time, but after boron he left a space and he named that element as Eka boron. Later, the space was filled with the element which is named as scandium. And the element which is placed instead of Eka aluminium after the discovery, it was named as gallium. Next, Eka silicon was named as germanium. Scandium, germanium. Okay. So remember this. So they are asking in competitive exams. For scandium, what was the name given by Mendeleev? So Eka-boron. Eka-boron means scandium. Eka-aluminium, gallium. Eka-silicon, germanium. Okay? Even he guesses the properties of these elements as well as means what type of oxides they will form, or when they react with halogens, how they will form compounds, or what are the properties of those compounds, and even he guesses the mass atomic weight of these undiscovered elements also. Okay? So that is the main merit of this Mendeleev periodic table. And coming to the other one, there is one more important point given by Mendeleev. Now coming to that point, he corrected the atomic weights of some elements. Okay? He corrected the atomic weights of some elements. For example, like for beryllium he corrected, as well as for osmium also he corrected. Okay? The atomic weights of some of the elements he corrected. Previously, for beryllium, the atomic mass or the atomic weight was calculated as around 13.5. But he corrected that atomic mass around to 9. Okay? So on what base he calculated the atomic mass? We need to know. So note down that in what way Mendeleev corrected the atomic masses, or how he calculated the atomic weight of the elements. He calculated the atomic weight. Atomic weight of an element is equals to equivalent weight of element into its valency. So we need to remember this one. Okay. Generally what we will write, equivalent weight is equals to atomic weight by valency. To calculate the atomic weight, the formula is equivalent weight of an element into its valency. Okay. So by this way, he calculated the atomic masses of some of the elements. Okay. So these are the main merits of Mendeleev's periodic classification of elements. Now let us discuss about what are the demerits. So what are the drawbacks of this classification? Let us discuss. Now, coming to the drawbacks of Mendeleev's classification of elements. Okay, we no need to bite at all these because from the information whatever we know about the Mendeleev, from that only we will come to know what will be the drawbacks. Yesterday we discussed about its construction of the periodic table given by Mendeleev. Now let us discuss his drawbacks. Now coming to the construction of the periodic table given by Mendeleev, we discussed one point. He arranged the elements in the increasing order of their atomic masses. Right? At that time only we discussed that. Is the properties depends only on the atomic weight? No. Generally the properties of the elements based on number of valency electrons present in there. Generally in chemical bonding lesson, you already learned all those in the lower classes, right? Now, coming to this, first demerit is This classification is based on, or his periodic law is based on the atomic masses. But we know the properties of the elements are not periodic function of atomic weights. How we prove? Just yesterday we discussed one example in the case of isotopes. If you see isotopes, yesterday we already discussed this one. The isotopes of carbon, for example, if you see, all are having different atomic masses. Okay? But coming to the behavior, chemical reactions point of view, all the three will form same type of compounds. Okay? So their properties are not much differ from one isotope to other isotope. Okay? So the periodic law given by Mendeleev was ruled out in the case of positioning these isotopes. There is no position for isotopes. We didn't place in the isotopes in the periodic table. Okay? Because according to him, the properties of the elements are periodic function of their atomic masses. Okay? But if you think it is based on atomic masses only, then he needs to place isotopes in the periodic table. But he did not place in the isotopes. Now for all these classifications till now, at present our periodic table also has one demerit. What is the common demerit is the position of hydrogen. Because hydrogen has similarity with the properties of first group elements as well as like alkali metals and the halogens. Okay? So we will discuss further how it is having similarity. Now coming to the position of hydrogen. He placed the hydrogen in the first group, but it is having similarities with the halogens also. That is why the position of hydrogen is a drawback. Now, the very important topic of Mendeleev is presence of anomalous pairs. So first we need to know about this term. What is meant by anomalous pair? Anomalous pair means what? Two elements. Okay? Anomalous pair means the pair of elements who are not following the rule. Okay? Who are the pair of elements which are different from the other elements. Okay? So let us discuss about it. Why they behave like an anomalous pair means what trend we followed regarding Mendeleev. He arranged the elements in the increasing order of their atomic masses. But in the case of some elements, the element with the less atomic mass is placed after the higher. Okay? Actually, after lower atomic mass, the higher one will come. But he placed the elements with high atomic mass before the lower one. Okay? So such type of pair of elements which are following the rule are known as anomalous pairs. Okay? Now coming to the examples for anomalous pairs. So first note down in the notes, because later we will get confusion what is meant by anomalous pair. So let us write clearly in the notes. Anomalous pair of elements nothing but the pair of elements which are not following the rule. Those are anomalous pair of elements. Why such type of anomalous pair of elements were observed means he placed elements with higher atomic weight before element with the lower atomic weight. Okay? Actually the alignment is like increasing order. So after a lower atomic weight, we need to get an element with higher atomic mass. But there are few pair of elements where the element with the higher atomic weight is placed before the element with the lower atomic weight. Okay? So such type of pair of elements are known as anomalous pairs. We need to remember the examples for these anomalous pairs, because in the competitive examinations they are asking out of the 4 set of options which represents anomalous pair of elements. Okay? So remember the examples. The best example, argon and the potassium. If you observe the atomic mass of argon is around 39.9, but coming to potassium it is 39.1. Okay? He placed argon before potassium. In the same way, now coming to other elements, cobalt he placed before nickel. This is one example. This is another anomalous pair. Coming to the other examples, tellurium he placed before iodine. Okay? Iodine is having 127.3. It is tellurium is having around 127.8. But he placed tellurium before iodine. Okay? Right? So these type of pair of elements are known as anomalous pairs. Note on this. Now coming to the next. Here, coming to the other drawback of Mendeleev's periodic classification of elements is he placed elements with different properties in same group. Okay? Generally a group means what? It is vertical column. We know he classified up to 7 groups into 2 groups, group A as well as group B. But in many of the cases there is no similarity between the properties of group A and group B. For example, you see he placed coinase metals. What are meant by coinase metals? Generally we know about this one, coinase metals using in the making of coins. Copper, silver, gold. These are known as coinase metals. These are placed along with the alkali metals. Okay? But there is no similarity in the properties of alkali metals and coinase metals. Alkali metals are highly reactive metals, but coinase metals are very less reactive metals. Okay? So such type of mistakes he did. He placed the elements with the different properties in same group. Okay? And also elements with similar properties, elements with similar properties are placed in different group. Okay? Elements with similar properties are placed in different groups. Actually, a group means what? Elements with similar properties. Okay? But the elements which are having similar properties are placed in different groups. The elements without similar properties are placed in same groups. Okay? So that is the main drawback for Mendeleev's classification. Now coming to the example point of view, coinage metals. Remember this point. Coinage metals means copper, silver, gold. Okay? Copper, silver, gold. So these three metals are known as coinage metals. Coinage metals are placed along with alkali metals. Okay? But the behavior of these two are different. But he placed in the same group. So that is the drawback for Mendeleev. Okay? As well as coming to the last demerit, the position of lanthanoids and actinoids. You may hear this word lanthanoids and actinoids. We know even in the present periodic table also the position of these lanthanoids and actinoids is a drawback because they are placed separately in the periodic table. Okay? So these are the main drawbacks for Mendeleev's periodic classification of elements. Okay? What is the major drawback? This classification is based on atomic weights, but later it is proved that the properties of the elements are not the periodic function of atomic weight. Okay? On what it will be based then? The properties of the elements generally it is based on electronic configuration or the number of valence electrons. Right? You may know about valence electrons. Valence electrons means what? The number of electrons present in the outermost orbit. Okay? Because the electron transfer or the sharing of electrons will be takes place in the valence shell. Right? So the chemical behavior or the properties of the element will be depends on the number of electrons in the outermost orbit, but not on this atomic weights. Okay? So that's why this periodic classification was ruled out. Now coming to our present new periodic table or new periodic classification. First copy this. What is the name of our periodic table? What we are following? You know, that was given by Moseley, which is known as Moseley's modern periodic table or long form of the periodic table. Actually, Moseley was classified or given the periodic classification based on atomic numbers. But later a small modification was done to this periodic classification by Niels Bohr. Okay? So what about this periodic classification? Let us discuss now. First coming to Moseley's modern periodic table. So keep the heading as Moseley's periodic classification of elements. Moseley's periodic classification of elements and periodic table, or it is also known as long form of the periodic table. Okay. Now coming to our discussion about Moseley's periodic classification of elements as well as modern periodic table, or it is also known as long form of the periodic table. Okay. Nowadays what the periodic table we are using? It is known as modern periodic table, also long form of the periodic table. Okay. It is obtained from this Moseley's periodic classification only, but a small correction was done by Niels Bohr. Okay, let us discuss it. Now, first coming to Moseley, what in what way this classification is mainly different from the previous classifications is all the previous classifications till Mendeleev is based on atomic masses. But coming to Mendeleev, Moseley, he given a periodic law which is based on the atomic numbers. Okay, so that periodic law is known as Moseley's modern periodic law. In the last class, we discussed about Mendeleev's periodic law. Now coming to Moseley's modern periodic law. In what way this law is modern? The same way as Mendeleev, only the thing, instead of atomic masses, he given the law based on atomic number. Okay? How he came to know the properties are based on atomic numbers, right? First of all, he has drawn the graph. He has drawn graph between square root of nu versus z. Okay? He has drawn the graph between square root of nu versus atomic number. We know capital Z means atomic number. So let us know. Nu nothing but frequency. We already discussed in atomic structure lesson. Nu means frequency of the emitted X-rays. Is done an experiment by bombarding the metal surfaces with a fast moving beam of electrons. Then the emitted X-rays is recorded. The frequency of the emitted X-rays was recorded. So that is the frequency of this emitted radiation. And we know Z means atomic number. Okay? So he has drawn the graph between these two. When he drawn the graph between the square root of frequency of these emitted X-rays and the atomic number, he got a straight line. Okay? Means both are directly related. Okay? So as the atomic number of the element is changing, the frequency of this radiation is also changing. Okay? So from this relationship, from this graph, he given a relation, that is square root of the frequency is equals to A into Z minus B. Okay? Z is atomic number, A and B are constants. Okay? Anyway, relation is not needed for us. Mainly we need to focus on what base he given the periodic law. He given the periodic law by drawing the graph between square root of frequency versus atomic number. Okay? Then he came to know both frequency and atomic number are directly related. So from that he concluded the properties of the elements are periodic function of their atomic number. Because when he draw the graph between square root of frequency versus atomic mass, he did not get a straight line. Okay, so there he concluded that the properties of the elements are not depending on atomic weights. Those properties depends only on the atomic number. Okay, then he given a law which is known as Moseley's modern periodic law. Okay. So now coming to the law. What was the periodic law given by Moseley? The properties of the elements. The properties of the elements are periodic function of their atomic numbers. Okay? Yesterday, in the Mendeleev's periodic law, instead of atomic number, you written atomic weight. Okay? So that is only difference. Everything remaining statement wise, both are same. The properties of the elements are periodic function of their atomic numbers given by Moseley. Okay? So the properties of the elements are depending on the atomic number. So as the atomic number of the element changes, the properties of the elements also changes. Okay? Now let us discuss about the table, periodic table given by him. Okay. Now before that periodic table, in the notes, mention one point. Already I told you, a small correction was done by Niels Bohr to the Moseley's modern periodic table. What correction he done is, according to Bohr, the properties of the elements are periodic function of their electronic configuration. Okay? Nothing but mainly the valence shell electronic configuration. Okay? So note on that statement also. According to Niels Bohr, the properties of the elements depends on the electronic configuration. Okay? The properties of the elements depends on electronic configuration, not only on the atomic number. Okay? Because atomic number gives information about how many electrons present in the atom, right? But coming to the elements with similar properties, if you observe, the elements with similar properties is mainly due to electronic configuration. Okay? Because no two elements have same atomic number, but still why the two elements are having similarity in the properties means because of their similar electronic configuration. Because of that, the elements have similarity in their properties. For example, if you observe, let us take lithium. What is the atomic number of lithium? Is 3. Previously, we already discussed about how to write electronic configurations. Now, lithium and the sodium, as we all know that lithium and sodium belongs to same group. These are called as alkali metals. Now the electronic configuration, if you see, They are 1s2, 2s2, 2p6. And if you observe the valency shell, what valency shell means what? The last shell. In the case of lithium, second shell is the last shell. In the case of sodium, this third shell is the last shell. This is first orbit, this is second orbit, and this is third orbit. Now once observe the both elements, lithium is having the outermost configuration, electronic configuration as a 2s1. So it is having one valence electron. This is also having one valence electron only, and both are present in the s orbital. So because of this, these two elements are having similarity in the properties. Okay, that is what explained by Niels Bohr. Okay, mostly given the table, construction of table, everything is correct. Only the thing he given that arrangement is based on the increasing order of their atomic numbers. But coming to the correction given by Niels Bohr, the properties of the elements are mainly depends on electronic configurations. Okay, the elements with similar electronic configuration will have similarity in their properties. Okay. Let us discuss one more example. We all know about fluorine, chlorine. We know both, we call them as halogens. Right? We know fluorine, chlorine belongs to same group. They will have similarity in the properties. Now let us see whether these are having same or similar electronic configuration or not. Fluorine atomic number 9. For an electronic configuration, 1s2, 2s2, 2p5. Right? So this is its valency shell electronic configuration. Valency shell means what? The outermost shell. Here this is inner shell. Now coming to chlorine, atomic number 17, its configuration is 2s2, 2p6, 3s2, 3p5. Once observe the electronic configuration of fluorine and then chlorine. What similarity we observe? Both are having the same type of electronic configuration. 2s2, 2p5, 3s2, 3p5. So same number of valence electrons. How many? Here 2, here 5. So total valence electrons are 7. Here total valence electrons are 7. Their atomic numbers are different, but their properties are similar because they have similar electronic configuration. Okay? Got the logic or not? That is what that point was given by Niels Bohr. Okay? Now let us discuss about the modern periodic table. First note on this. Now, coming to the construction of long form of the periodic table. So, keep the subheading as construction of modern periodic table or long form of the periodic table. You don't be lazy. You write clearly as a periodic table. But later in the recent time you may think what is PT. Okay? Now, yesterday also we discussed a periodic table means it will contain horizontal rows as well as vertical columns. What we call as vertical columns, we call the vertical columns are known as groups. These horizontal rows are known as periods. Okay? Now coming to this long form of the periodic table, let us first discuss about periods. Periods means what? You should have clarity about this word. Periods means the horizontal rows. There are 7 periods in the long form of the periodic table. Now coming to the groups, means the vertical columns. If you observe, there are 18 groups in the long form of the periodic table. Okay? Got the thing here in a long form of the periodic table. How many periods means? There are 7 periods. How many groups? There are 18 groups. Okay? Now individually let us discuss separately about periods as well as groups. First let us discuss about periods. Let's get this already as periods. Okay, I think every one of you may have idea about periodic table. Better, once open the textbook, look at the periodic table. So by observing the table, if you listen this video, well, if you listen this class, then it will be useful to you. Okay. Now once look at the first period, means the first on the top, whatever the horizontal row is there, once look at that row, that is known as first period. What you observe regarding the first period? Okay? If you observe that first period, there are only 2 elements are present. Okay? The first period contains only 2 elements. So that is why first if you observe those 2 elements are present. The first period, the topmost one, if you observe there, it contains hydrogen as well as helium. Okay? First period contains only 2 elements. Starts with hydrogen and ends with the helium. The extreme left hand side is hydrogen. The extreme right hand side is helium. Okay? Hydrogen 1, helium 2, atomic numbers. So because of presence of only 2 elements, the first period is known as shortest period. Okay, the first period is known as shortest period. And even this first period is having one specialty. Okay? In one way, it is different from all the remaining periods. The specialty of this period is, this is only the period which contains only gaseous atoms. Right? Once observe carefully, hydrogen is a gas, helium is also a gas, and we know it is a noble gas. Okay? So this is only period which contains only gases. But as coming to the other periods, if you see, they contain solids mainly as well as some gases also, or sometimes liquid also. Okay? So that is why the specialty of the first period is it contains only gaseous elements. Okay? So in the notes somewhere you wrote down that point. Now coming to second period. Second period, if you observe, there are 8 elements in second period. If you observe the 8 elements, the first starting with the lithium and ends with the neon. Okay? So these elements starts with the lithium with atomic number 3, and we know neon atomic number 10. But this period is known as short period. Coming to the next period, that is third period. Third period also contains 8 elements. Okay? So both second period as well as third period both contains of elements. So that is why both are known as short periods. Okay. Second period, third period, both are collectively known as short periods. Now coming to the third period, starts with the sodium and ends with the argon. Okay. Now coming to fourth period. Coming to fourth period, it contains 18 elements. Okay. Now it is previous two containing only 8 elements, but coming to fourth period, it contains 18 elements. If you have doubt, I told you, open the diagram, open the picture of periodic table. You check from the fourth period. From fourth period onwards, what happens? Between the first two and the next last 6, there is one more block. Generally, we know those are D block elements. If you count, there will be 10 groups. Okay? So that is why total you will get 18 elements. The first two, generally we call those first two groups as S block elements. And the last 6. Okay? So those last 6 are P block. We will discuss furtherly. Between them there will be 10. Total 18 elements will be there. So starts with potassium and ends with krypton. So this period is known as a long period. Okay. Now coming to fifth period, this will also contain 18 elements. So both fourth and fifth periods contain same number of elements. So that is why both these two are known as long periods. Okay. Second and third periods are known as short periods. Fourth and fifth periods are known as long periods. And coming to the starting, the fifth period will be starts with rubidium and ends with xenon. Okay. Now coming to the sixth period, it will have 32 elements. Okay. When compared to the previous one, there will be 14 elements extra. Once you count in the tabular form, are you getting the 32 elements in the sixth period? You won't get that. Because if you observe the tabular form wise, length of fifth period and the sixth period is same. Okay. So it will be like 18 elements only it appears. But the sixth period contains lanthanoids also. If you observe the bottom of the table, there you can find lanthanoids. Starting from lanthanum La to the last element lutetium Lu. Okay. I will explain all those things coming topics we will discuss. So first briefly, how many elements are present in sixth period means we should say 32. Sir, how 32? 14 generally are present. Sorry, 18 generally are present as like the previous period. But along with these 18 elements, 14 more elements which we call them as lanthanoids are also present in that period only. So remember, lanthanoids belongs to sixth period. So that is why we will get 32. But lengthwise it is same as fifth period only because lanthanoids are placed at the bottom, but they belong to sixth period only. Okay. So there are 32 elements in the sixth period. The starting element of sixth period is cesium, and the ending element of sixth period is radium. Okay. Sorry, not radium, radon. Okay. Helium, neon, argon, krypton, xenon, radon. Now this is called as longest period. Coming to last period, this will also contains 32 elements. Starts with FR means Francium. Okay? And ends with 118th element. How to name that element, everything we will come to know. Actually, it is an octium. So UU. Actually, it is known as incomplete period. Okay? The last period is known as incomplete period. The first period, shortest period. Next two are short periods. Next two are long periods. And sixth one is the longest. And the last one is known as incomplete period. Okay? So this is the minimum information we need to remember about the periods. So first copy this. Then we will discuss about groups individually. Okay? Just not everything, all the information about groups. We will discuss even in the first period, second period syllabus. Generally it is divided. A brief information about the groups we will discuss next. The first copy is. About the groups, let us discuss in the next class. Okay? Now copy this about the periods. Thank you.